treasurer, counselors, and all those. We need people with us so that we can take it forward, all right? But for now, obviously, I want to say again, another special thanks to the current team for putting this conference together. For the authors, thank you for being here. We are ready to listen to you and all the delegates. But now at this particular time, I think it's my great pleasure and honor to introduce our keynote speaker for the morning. He's a friend of ours, a friend of the conference, of our conference, very, very supportive. Prof. Edwards, we're so happy for you to be here. I won't even go maybe into more details to describe the impact that you make in the construction industry, in the academic, your support for the conference. Thank you for being here. And I'm hoping if you are ready right now, like I heard that you've been ready before a lot of us, please, if we can put those emoji hands together and welcome Prof. Edwards for us this morning. Thank you. Over to you, Prof.
Hello, good morning. And thank you, Prof, for that wonderful introduction this morning. I couldn't have said it better. Absolutely fantastic, very inspirational and motivational. Thank you. It's an absolute pleasure to be here again today. It's the cheapest flight tickets I've ever had to South Africa. But I'm really looking forward to enjoying this presentation and talking to you guys today. I hope you enjoy the presentation. This is just a snapshot of some of the research that I'm currently working on in this field of digital. Perhaps one of the first academics to really start working in the area of Industry 4.0, and the work goes from strength to strength. And we're currently working on a new research contract with Highways England in this area. For those of you who are on CNBR will see that 2 fully funded PhD studentships and soon to be a research fellowship have been advertised on CNBR and also LinkedIn. So the work continues to grow, and as I say, what I'm going to present today is just a snapshot. So to give you a good overview of some of the work that we're doing here in the UK. And as I say, I'm more than happy to take any questions at the end of the presentation. And I look forward to meeting you all individually. So there's some details from myself. For those of you who can't see me on camera, lucky you. My email details, contact details, ResearchGate and mobile number. Anyone wishing to contact me after this, you know, probably WhatsApp is the best way of dropping me a message because I've always got my phone near me. You'll see that I'm currently working at Birmingham City University in the UK, but I've also got a distinguished chair at University of Johannesburg, and then visiting chairs at NUST in Ghana, and another one at University of South Australia with Nicholas Gillespie. I work extensively with Dr. Reza Hosseini, who is, in my opinion, one of the brightest academics in the area. So you've got a fantastic presentation coming after me, and he'll be a real treat for you guys, as he'll give you some cutting-edge presentation in his area of digital and BIM, Internet of Things, and other related areas. For my presentation today, I'm going to cover a brief introduction to Industry 4.0. Most of you will probably heard of Industry 4.0, or as some academics say, Construction 4.0. Construction 4.0, I'm not quite sure where that terminology came from, but it's in my opinion, a vacuous term, because the whole world is talking about Industry 4.0, and I don't see why we need to make up new terminologies to cover something that is already well established. I'm going to provide you with some case studies, 2 case studies in example, one in my own area, one with a project that I led on with a colleague of mine, and also hopefully challenge peers and colleagues today to think about the opportunities and the challenges ahead. So a timeline of Industry 4.0. I was here the other day in Telford in the Black Country, UK. That's 1700 when the Industrial Revolution started. And literally, the ground, the environment, they call it the Black Country because the environment and the landscape was absolutely decimated. And they say that this is where Tolkien based his book on the Lord of the Rings, because the ground was literally on fire with coal that was burning to make iron, to make steel, to make bricks and other resources that had previously been made by hand. All of a sudden, we'd moved to this mass production model, and we made a huge step out of the dark ages into a more industrialized setting. We then moved on to Industry 2.0 with Henry Ford there, and economies of scale, factory chain productions, mass production of cars, which was a new thing at the time, perhaps related to John Adams and the division of labour. Henry Ford certainly took that on board and adopted that, so you could literally stand at the side of a production train and just attach screws or just attach tyres all day for 8 to 10 hours of a working day. We then realised that man was susceptible to problems, acts, emissions, other things that could lead to errors in the process itself. So we moved to Industry 3.0, which was to focus on automation and using robotics, mainly in aviation, some in manufacturing, and particularly in automation and the automotive industry. So that was a major leap forward, but more recently, we have adopted a more digital solution. And that digital solution contains a whole wealth of interconnected technologies that coalesce as one and work together. Those technologies include things like 3D printing, augmented reality, cloud computing, cyber security, smart sensors, Internet of Things, location detection, and robotics and AI. It's that coalescence of these technologies that are working together as one, so that information and big data is instantaneously processed, and it removes, or largely removes, people from the process to mitigate acts, errors, or emissions that may be introduced into that process. Just about every developing country on the planet is now working towards Industry 4.0, and there are other developments in this area that I will be perhaps talking about next year when my first research in those new areas come out. For now, we are seeing an explosion of research, particularly in construction and civil engineering management. And if there are any PhD students out there looking for a topic, then this is certainly a very, very interesting topic to get involved with. And I would like to say, working with Professor Hupt, that I do work extensively with South African academics, and it would be good to meet new people and work with others in this field. So let's look at the first case study examination, the first of two. This one's looking at earth moving and machinery. I was working with a company called JCB on this project who sponsored the work. The work is still ongoing, and particularly this week has been horrendous because teaching has started, and at the same time I'm trying to finish some of this research too. But it's also very enjoyable. And for the first item of work that I worked on, we looked at a rough terrain telescopic handler, or as they say in the UK, simply a telehandler. A telehandler is basically a materials handling piece of equipment and that will take pre-packaged, prefabricated components and distribute them around a construction site. One of the main problems with this type of machinery is longitudinal, that's across the axes, a transmission of the machine stability, and also lateral stability across the final axles at the rear of the machine. So these machines are tipping over all the time, and they tip over because as they're lifting a load, the center of gravity changes on the machine, and therefore instability is induced. So what we did was to set up, that was me in a very cold winter evening some years ago. What we did is set up some test environments on these machines, and we sat out in quite a dull and dark, I seem to think it was quite damp day. We fitted all sorts of digital devices, GPS and GIS, onto the machine so that we could monitor the performance of that machine via satellite link and Internet of Things. So we could monitor the stability of the machine. That was downloaded to a server which contained big data, and that itself was then input into an AI algorithm. This was a back propagation algorithm, feed forward neural network with back propagation. The back propagation we used was a Marquardt algorithm, and that algorithm then calculated the instability of the machine. Fitted to the machine was a number of sensors, and specifically we had two sensors on the rear axles of the machine, so that as the axles were loaded up with a dead load from the material being handled, the sensors actually moved closer together to indicate the deflection in the rear axle. And that was the information that we were constantly monitoring. And what we actually found was that the safe load indicators, something for Professor Hupt and his team, the safe load indicators on the machine couldn't differentiate between the load that was being transferred to the rear axles, thus creating an unsafe condition in the machine. And they couldn't differentiate between that and between the machine simply traveling on level, firm ground. And this is why we put those sensors on those axles to try to differentiate between the two. Now, that just doesn't have a safety implication, because what was happening was, as the machine was traveling, the machine would stutter and stall because the safe load indicator connected into the machinery would switch off the hydraulic pressure, thinking the machine was unstable, when in fact it was perfectly safe, and therefore we were losing a great deal of productivity performance on the machine. So what we did, we disabled that safe load indicator. We relied on the sensors and the satellite communications fitted to the back of the machine. And lo and behold, with the safe load indicators on, we could see that, okay, productivity performance at the various levels and ranges of productivity performance between utility rates of 20% to 100%, they were reasonably good in terms of materials handled. But when we turned those safe load indicators off and relied on the sensor-based technologies, the productivity performance rocketed to almost 2 million kilograms per 8-hour period. Now that's a massive jump, perhaps 22% jump in productivity performance. And what it also does, it also cuts down on the amount of emissions from the engine of the machine itself, because you can do more using less fuel. So your NOx, your CO2, SO2, all these other chemicals that were emitted from the vehicle could be reduced substantially. And that's all using Industry 4.0. And today, those sensor-based technologies that you can use for Industry 4.0 are very, very cost economical. So we're not talking about a major expense here to fit technology to machinery. So I think that's quite a compelling case for the first case to show exactly how much more performance you can get out of a machine without losing the safety or the inherent safety of that machine. So the next phase of development, we're going to go for a fully automated machine with driverless technology. I've just released a paper on driverless technology, which I'm hoping will get published fairly soon. We're already there with the technology. The original equipment manufacturers, the OEMs, are looking actively at driverless technologies, but their biggest fears is litigation and legislation. We just don't have the legislation available at this stage to protect users of these machines. So if you have an accident in a driverless vehicle, if the driverless vehicle causes an accident, who do you sue? Do you sue the manufacturer? Do you sue the people who provide the network connectivity? Do you sue the person who's actually sat in the vehicle? It's a very grey area of legislation. And so we have the technology, we have the solution. What we haven't got is the legislative framework to enable driverless technologies to become a reality. So there's a great PhD in that area there, if anyone out there is listening and interested in this area of research. Case study 2 looked at BIM. I think it's fair to say that BIM now has just about burst as a bubble of research, but there are some good areas of expanding BIM now. I know Dr. Hussain is doing some fantastic work in terms of connecting Internet of Things to BIM. And this is where I see the developments moving more towards that Industry 4.0 solution where we're connecting and coalescing with different technologies. This one was led by my research associate. This was Dr. Yahia Al-Said, and it was sponsored by a grant, only a small grant, about £200,000 for Innovate UK. We recently submitted the final report for this grant, which was rated as outstanding, which is the highest classification you can get, peer-reviewed classification from the awarding body, which is absolute fantastic news. And we're currently now writing a second grant. So let's look at BIM. Well, if we take this average office building there, small office, that's a little design group there, 4 people, all hammering away at the keys, trying to use CAD as well as BIM, and transferring CAD drawings into BIM, and all sorts of mistakes and errors from those 4 individuals who are fantastic people, but they are human and they open to human error. And what we found was that these designers were very separated from the client, and they're also very separated from the manufacturing process. So our ambition was to link the upstream supply chain to the client, to the downstream manufacturing process, and to have the design integrated within both streams of that manufacturing process. Here's one of the machines that is automated at the moment, and what tends to happen is that the drawings are hand-fed down to the guys on site, and here there's another opportunity for wastage of materials and errors of people working in the factory on CNC machines and similar, who have to take the BIM design and implement it in practice. So the idea, as I say, is to integrate this right from the client, right the way down to the machine train, and remove humans from that process. So the first stage was to work on an information system to define and delineate what the system actually represented. This alone, as a data flow diagram or an information system, is worthy of a PhD in itself. To sit down and work through a process and understand the process and redesign a process is worthy of a PhD. So again, anyone out there who is looking for PhD topics, there are some great opportunities in this area. Once we understood the process and we understood what we call swim lanes, we then formulated those swim lanes by first taking a relational database, and using that relational database, we tried to link up all the different items of information that could be supplied from the BIM model into the organization so that we had total joined up thinking from sales and client interface right the way down into the final product manufacture. And what we then produced is a series of swim lanes broken down into 5 easy stages, from preparation, beg your pardon, and conceptualization through to design, production, construction, and then finally asset management. Now, I emphasize asset management because it's increasingly important these days, and again, there's another PhD in here for a bright young person to take on board. Asset management is critically important because it's about adding added value to the client today, where the client not only is sold a product, but you work with the client and participate with the client in what we call the after sales market. If you sell a product, you may get, say, 40% of your revenue, but by capturing the after sales market, by providing maintenance and parts and other components, you can generate potentially another 60% of revenue just from that after sales market in asset management. And this is where technologies like BIM come into play, because having those abilities to manage the asset through BIM and all the information that you've contained within BIM really allows you to work with clients and literally, click of a button, ordering of materials to them. In the production phase, you'll notice that we're also using augmented reality. And this again is a fantastic concept because prior to, once they've actually purchased the product, we can actually talk the client through the process and allow them to visualize the product that's placed in situ. We're also using scan to BIM. So all of the objects that are contained within the BIM model, you can literally walk around your asset at a later date and scan those objects and bring up a whole range of geometric and rich semantic information on those projects. So this was a fantastic opportunity here, and this is now developed. It's now being used in practice, and we're now working on several multi-million-pound contracts which want to adopt this technology and the new technologies we're currently working on. So it's a fantastic success, and it all started off with an idea. How do we make things easier for people out in industry to participate in Industry 4.0? So the client doesn't see all this back-end information. They don't see the complexities of the model we've developed. All they see is a small application that they can use. So we take the BIM model as a process now, talking to people. There's an upstream process to the architect contractor, downstream to the manufacturing. Those two talk to each other through the client delivery. And then that goes over to the facilities management team handover, updating of that FM team via the BIM model. And that takes you right the way through to demolition so that you know exactly what products are contained within an asset if you decide to asset strip or safely dispose or even reuse those assets at a later date. So this is a fully integrated process that we have developed in this case study. Next stages of development. Automated voice recognition, we've already got that in place. Look out for the paper in that area, it will be coming out fairly soon. Update and amend the BIM model using voice control. Again, we've got that out, so that should be coming out fairly shortly. So please look out for that paper, it's a fantastic paper. And one thing I would like to say is that, you know, it's very easy to take the credit for all these developments, but I myself find that I'm working with a huge number of people across the globe, and it's, you know, a special thanks to these people that I'm able to make these advancements in this subject area. So from my offices in the middle of England, I'm working with people in Spain, in America, in the US, in Brazil, in South Africa, obviously with Professor Hucht and Professor Thwaler and Agbab Boa, and also in Hong Kong with people like Heng Li, Albert Chan, a good friend of mine, Joseph Lai, and of course Australia with Professor Hussain and Nicholas Shalesti and others. So it's joined up thinking. It's about working together. It's about being part of a bigger team and taking small ideas, working with colleagues and building them into other projects that you can liaise with and go on to develop some fantastic research that has real impact and value. And that's what I would urge all of my friends and colleagues in South Africa to focus on, because it's very easy to slip into the publication or peril paradigm, which is where you're basically publishing lots of papers, but those papers have very little value. What I've tried to demonstrate to you today is that, you know, if you want to become a professor yourself, and I'm sure there are many bright academics listening today, and I would like to think that many of you are far brighter than myself and will go on to much better things than myself. You know, that there's a real opportunity here to change the way you work and set your stall out to become an international professor yourself one day and replace the old farts like myself and Professor Hubt. Sorry, Theo, I believe you're 10 years younger than me, so that was said tongue in cheek. That was a joke, by the way. Okay, so the bigger teams, multidisciplinary teams, we've covered that. Working with, of course, remember this, you need to work with construction organisations, but also cast your net to other organisations. I also work in business. I work with manufacturing companies and professional bodies, and you learn a lot about the problems that people have purely by conducting observational research, where you work with people and you observe the problems that they've got in the workplace. And if you can do that, you also generate ideas. The other side of the coin is to work with, now in a construction discipline, if you're interested in digital, you have to work with people in IT, cyber, AI and other hardware engineers to make sure that you're working as part of a bigger collaborative team. That's the way we seem to be going these days in digital. And I would certainly encourage people to work in those bigger collaborative teams, because that's where you're going to win your first grants, and that's where you're going to publish your best papers in Q2s and Q1 journals. So yes, work as part of a bigger collaborative team. So that ends my presentation this morning. I hope it's given you a good overview of the really a sort of vignette, if you like, of practice of some of the projects I'm working on. These aren't the only projects. There are many, many more. I've got also projects in health and well-being and hand-on vibration, all sorts of different projects going on. but hopefully that gives you a little bit of insight and also gives you some flavour as to what we're doing in the UK, which hopefully compares well against some of the presentations. I believe I heard they were excellent presentations yesterday. You'll be able to compare and contrast between the two. So thank you for listening. I'm now going to stop sharing and take any questions and answers from the audience. Thank you.
Thank you so much, Prof. I was just trying to get my video, but I see it's doing something else. Let's see what, Edwin? Okay, there we go. All right. That was Prof. David Edwards. We heard his presentation, really, really insightful. And you've given us lots of ideas because we seriously have lots of students who want to research in this area, sometimes very zealous, but not with the ideas. So maybe what we're going to do at this point, hi, Prof. Can you hear me? You can wave at me if you can hear me. Yeah.
I can hear you very well, thank you. I haven't shaved this morning. I was up
it's all right. You're still looking good and the light is shining on you.
Thank you.
Yeah, so we wanted to change the program a little bit, but I think it's still fine. We can still, I know Dr. Riza is ready for us, but I think if we've got questions now, maybe we could take one or two. We wanted to find out how your time is. Are you able to wait for Dr. Riza as well to present, or do you want to take your questions now?
If I could take a few questions now, that would be useful. But I don't mind just maybe a couple, and then I can always answer some more after Dr. Reza has spoken about his research. And I will say that's going to be a cracking presentation. I've worked with Dr. Hosseini for a number of years now, and he really is a true international scholar in the field. I've stunned everyone to silence, so I can only assume there's no questions.
Of the 4I era, all the different things, Internet of Things, where the beam is sitting and things. I think everybody's just trying to see which strand they're going to go on. But if there are no questions, then I think my work becomes even much easier. It's just to thank you, say thank you so much. Probably if we have more questions, they might be coming, we'll just send them through to you. So thank you so much, Prof, for that really wonderful. Yeah, I'm thinking about it as well. I'm seeing where 3D is and all that. Thank you. All right. That is Prof. David, our Professor of Plant and Machinery and Management from Birmingham University. Now it will be time for me to introduce the next speaker, but maybe before I do that, I probably didn't also introduce myself. I just assumed and went in and started speaking. My name is Kahilo Kajimoshakantu. I'm the president of Asocsa, and I'm also the head of department at the University of the Free State. As I say, the only state that is really, truly free. So welcome to everyone. Now I would just like to take this wonderful opportunity to also introduce our next keynote speaker. He's in Australia.
Good morning, Dr.
He's going to talk to us about it.
Yeah, are you, okay. I don't hear anything.
Hello?
Ah, there you are.
Yeah, I'm here, yeah.
All right, so your sound is good.
Yes.
If you would like, I'm not sure if your settings are high enough, but you should be able to be audible. Otherwise, what you can do is just try maybe to speak a little bit, just a bit louder. And then everybody that's having bad sounds can actually hear you.
Okay, is it good now? Yeah.
The floor is all yours. The floor is all yours. Thank you so much.
Okay,
My
good.
screen, I just need to remove my screen, sorry. Or Edwin, you can do that for me as well, because I think probably my screen is sharing.
No, yes.
No. Okay. No. I think you may share your screen.
Yes,
no?
Sure.
Thank you so much and welcome. Thank you for being here.
Thank you for having me. It's a pleasure. It's around 7 p.m. in Australia, so it's a bit dark. I'm sorry for the dark environment here, but I try to. Okay, do you have my screen now?
Yes, we do. Thank you very much.
You're welcome. Okay, so, and it's the PowerPoint, yes?
Dr. Rizzo?
Yes.
Oh, there you are. I was about to ask you to do that. That's great. Thank you so much.
Okay. I was listening to David when I joined, and I think that what I'm going to discuss today is somehow in line with what he presented, but from a different perspective, from the perspective of Australian government and how they are approaching the enhancement of the construction industry in terms of digitalization and transformation to a digital industry. So what I'm going to share with you today, first I'm going to talk about some problems of the construction industry and the concept of digital transformation. Then I'm going to introduce the concept of digital engineering, which is something I believe unique to the Australian context. This term hasn't been used in other part of the world in the construction industry. If you look into the strategies of different governments, you can find this term in the Department of Defense of the US. They use the same term and they have a document digital engineering strategy. But if you go to the context of the construction industry, I think this is not being used anywhere else but Australia. And then at the end, I'm going to tell you about the digital strategy, digital engineering strategy in Australia, and how we are developing the strategy and promoting the idea of adopting and implementing digital engineering strategy in the infrastructure sector. I'm sure you have seen these things before. The problems of the construction industry, we are way behind other industries in terms of enhancement of productivity, in terms of our performance, in terms of the value we produce out of our activities. So you can see that we are mostly affected by delays in completing projects, in budget overruns, cost overruns, and delivering projects with over budget and late completion. And if you look into the productivity figures compared to other sectors of the economy, you can see that the value added per hour work for other industries has increased significantly in the last around 50 years. For example, for agriculture, we have a better value 16 times more compared to the construction, which we have an added value of 1.1, which is not comparable at all, and shows that we have huge problems in the industry. If we look into some sayings from people in the industry, from policymakers in the construction industry, so I'm referring to that from Canada, Icon Group. Looking at construction projects today, I do not see much difference in the execution of the work compared to 50 years ago. So we are always and have been always labor intensive. We rely on information, and as you know, construction is an information and data intensive industry. So where are the problems? If you look into the analysis of information flow across different industries, you can have a sense of the type of problem we are dealing with. So for manufacturing, you see the concentration of data information, the links between different parts, the links between different entities, and where we can find saturation of data and information in some nodes. In media and entertainment, the same. Financial services, they are perfect. Software, good. And when we look into the construction industry, we can have a feeling of where the problems lie. So we have scattered entities, weak links between them. We have dispersed elements of the supply chain, and we can see that compared to other industries, the links, information, and data exchange between these entities and parties involved in the construction industry, we can't compare them. So it's weak, to say the least. And the ability to share project information is the top factor affecting collaboration in the construction. So this is the problem. Data, information exchange, and lack of proper management and share of data and exchange across different parties and stakeholders of projects, portfolios, and programs. So what we try to do, we recognize data as the core capability of digital transformation. What we try to do, integrating people, processes, and information across the life cycle of all assets. Data and information should be accessible to all key players and key actors of the industry, and getting the right data and information to the right actor at the right time. These are the solutions to deal with this problem, as you see on the screen. So if we want to summarize that into two items as our rule and guideline, a golden thread of data and information throughout the asset life, we need that. And all actors understand the immediate and future data and information needs. Information needs, data requirements by clients, by actors in the supply chain of the construction. So we have this figure. It shows what we are going to do for digital transformation, people, processes, and technology. This is business transformation. When we go to digital transformation, to the next step, we have the added element of data here. So data sits at the center of digital transformation, and it's the core element that integrates people, processes, and technology together. In other words, it's crucial for all employees, for all parties involved in the construction industry to learn how to speak data, how to talk to each other with data and elements of data. So, to address the problem in Australia, in the construction industry in Australia, the movement towards BIM started in 2004. This document was released, a vision for Australia's property and construction industry, Construction Vision 2020. So this document predicted that to resolve the issues, as I mentioned, the solution is BIM. So the document highly recommended shifting to BIM, adopting BIM, and using BIM and digital modeling as the remedial solution. And after that, before 2018, all professional institutions, organizations, and professional groups in Australia all agreed that all policies and recommendations must position BIM and promote BIM to resolve all the issues of the construction industry. This included Australian Institute of Architects, Consult Australia, Institute of Building, Construction Industry Forum, and Australian Procurement and Council, among others. It's a long list, so I'm just referring to the major ones in the market. All agreed that BIM is the solution. And it made sense because in theory, if you look into books, into journal articles about BIM, BIM is capable of supporting data visualization, information management, and documentation. So it's a good tool. It's an effective procedure and tool and methodology to manage data and information for the supply chain of construction. It can link traditional information management processes to object-based models and combine all of them, geometric and non-geometric data, with each other. And it can focus on the exchange of structured data across the project's life cycle. That's what we wanted. That's what we thought is the solution to address the problems of the construction industry, these three. But it was only in theory. It was written in journal articles and books. What happened in practice? So up to 2018, when experts assessed the development of BIM in Australia, they found out that BIM usage beyond the design and construction phase is low. BIM is not ideally used across all phases of assets life cycle. This has been written in many journal articles in 2019 and 2020, so it's not something specific to Australia, but this was the reason for the movement towards digital engineering. And the most of the clients and people on projects mostly use BIM to drive cost and time efficiencies in projects. So this is another problem. They didn't go beyond projects. They used BIM in projects and they never got beyond the boundaries of the project. So they made the decision in some sectors of the government of Australia, specifically in New South Wales, to go beyond BIM. So they thought that BIM hasn't been that effective as we hoped for. And the best solution to address the problems of BIM is integrating BIM with other digital technologies and processes. So there might be some solutions to address BIM issues, but probably the easiest one, probably the best one might be to integrate BIM with the digital technologies that we have in the market and other processes to go beyond BIM and get what we want from BIM. So this part of the government, Transport for New South Wales, which is the main body in charge of delivering transport projects in New South Wales, the largest state of Australia, they started releasing digital engineering frameworks and standards. So they released the first part, or version 1, in 2018. The second version, which included the documents that you can see on the screen, in April 2019. Version 3, or release 3, was available at the end of 2019, and they are going to release version 4, or release 4, in 2020. We haven't seen that as of now, but I think they are going to release it probably sometime in November or December. And each of these releases included a couple of documents. For example, the release number 1, Digital Engineering Standard, Part 1, Concepts and Principles, Part 2, Requirements, Interim Approach, Digital Engineering Framework, Terms of Definitions, and Digital Engineering Execution Plan. Templates were provided in the form of PDFs, Excel spreadsheets for implementing each of these elements in projects and for contractors. So what's the meaning and what are the foundations of digital engineering as we consider? What we do is that technological innovations are assembled to allow for an integrated digital component-based approach that supports life cycle activities and develops the culture of the stakeholders to work more efficiently. So this is what we must do for digital engineering, creating a seamless thread of data and information through the product or asset life cycle, achieved through interoperability across heterogeneous systems, integrated information management, and data exchange. These are the foundations and principles of digital engineering. And this figure shows digital engineering strategy: provide an authoritative source of truth, establish infrastructure environments, incorporate technological innovation, and formalize development and use of models. To define digital engineering in simple terms, we must convert all forms of data and information into digital components. So anything that we have must be converted into a digital component, or DC. Systems and its elements, processes, equipment, product, parts, functions, services, whatever we have, must be presented in the form of DC. And we also need an authoritative source of truth, or AST, to provide a repository and access portal for all these DC elements that we have. So for example, anything related to management, anything related to finance or management must be converted to digital components. Anything about manufacturing elements of the work must be converted to digital components, systems, design elements, product support, and specialty engineering elements all become digital components and all shared, integrated, and stored in this AST. This is the basic component of digital engineering, and this is the same. If you go to the Department of Defense of the US Digital Engineering Strategy, they have the same definition for digital engineering. So what type of data we have to deal with in digital engineering world? Across the different stages of a project: planning, maintenance, operation, and customer or operation. We have a structured data. We produce big data. If we use sensors or other elements, we use big data. And we want to have open data and share it with operations people and customers. So with that background provided for digital engineering, Transport for New South Wales defines digital engineering as a collaborative way of working using digital processes to enable more productive methods of planning, designing, constructing, operating, and maintaining our assets. And the figure comes from digital engineering framework. So we have asset data, we have 3D BIM models, we have time elements, we have cost elements, document management elements, GIS, requirements management, risk management, whatever that we have will be integrated and converted to digital components to be integrated in our storage of data and shared with other stakeholders. So this is my definition, actually. We have written a paper to define the concept of digital engineering for students and for people in the industry who are confused between BIM and digital engineering. If we consider BIM as one part of the digital engineering concept, BIM is the core of it. So everything will be defined around BIM. Other technologies or technological innovations that we must use to form digital engineering can come from the pillars of Industry 4.0. So Internet of Things, VR and AR, drones or remotely piloted aircrafts, blockchain, AI, cloud computing, GIS, and big data, all integrated to form digital engineering. What we can use as the distinction points between BIM and digital engineering are shown here. So BIM is mostly related to projects. BIM is designed for projects and to resolve the issues related to projects. When we move beyond BIM, when we move beyond the boundaries of BIM and go to the realm of digital engineering, we can address the problems of program and portfolio. So if we go to the hierarchy defined by PMBOK or project management body of knowledge, we have 3 different levels. BIM is allocated to project, while beyond BIM, digital engineering can also resolve the issues of program and portfolio. Another distinction between BIM and digital engineering as we consider it is that BIM is mostly about efficiency and productivity, When we move beyond BIM to digital engineering, we are concerned with business and strategic values. So as you see, we move from project and efficiency to program portfolio. For a big organization like Transport for New South Wales, we try to enhance business and strategic values. BIM is not really concerned with strategic values of the organization or business considerations. It's mostly about project and efficiency. So about, if I want to give you an example, how Transport for New South Wales defines the benefits of digital engineering. So if we consider the problems of variations in delivering projects, a scope change, delay, equipment, part supply, underground utilities, all are problems. Contracts are unclear, resource availability as another problem, and unforeseen conditions. So these are the benefits that we can gain out of using digital engineering for each of these sources of problems. Digital site survey can be a solution, federated models, requirements, traceability, linking data for modeling of program change impacts, construction sequencing. So these are the responses provided by digital engineering to address each of these issues. For example, for underground utilities, GIS and enterprise content management metadata, tagging to retrieve information for underground utilities in future applications. Site modeling, including utilities, is federated and assured. So we have access to all these elements of data and information to address the problems we have here. So this is a major source of confusion in Australia, that people get confused when they refer to BIM and digital engineering. Some people say they are the same. Some people say that BIM is a part of digital engineering, which is what we think. And others say that BIM is an obsolete concept and we must move beyond BIM and go to digital engineering. So we produced this table to show the similarities and differences. If you go to similarities, both BIM and DE rely on open communications, information exchange. We need collaborative decision making, early participation and contribution of all key stakeholders. Integrated processes for both of them is a must, and data and information across the entire supply chain of construction. This is what they work with, data and information. What are the differences? So DE has a greater emphasis on product and asset life cycle, as opposed to BIM, which is mostly used in design and construction. DE has greater emphasis on systems integration. BIM is designed for project level, but DE targets business and strategic values for programs and portfolio. So it goes beyond the project level. BIM relies on one methodology, where DE is a coalescence of various engineering methodologies, including BIM. So BIM is one part of the DE. BIM puts emphasis on modeling of facilities, where DE is business analysis of various digital components. BIM is a construction term. Nowhere else we use BIM, whereas DE is industry agnostic. So as I mentioned, DE is a term and concept used in the defense industry in the US. So that's a table showing outcomes compared to benefits in front of benefits. I think I have to move quicker. This is a YouTube video produced by Transport for New South Wales to introduce the release 3 of the digital engineering framework in 2019. I think it's 4 minutes, but I try to move quicker, as I know that I'm standing between you and the morning tea and people are getting probably angry with me. So this is the development of BIM to digital engineering. So pre-program, we had the concept of BIM. In a stage 1, they adopted the the idea of digital engineering for rail and work streams, strategic, technical, commercial, technology, and training were recommended and introduced. Future concepts is to adopt the digital engineering framework and standards for roads, digital asset life cycles, commercial management, and business engineering. So these are the future programs in Transport for New South Wales for adopting and implementing digital engineering. I think we come to the end of my presentation. I'm hoping I was on time, and I'm happy to have questions and discuss any clarification if needed. Thank you so much, and thank you for having me and your involvement, my involvement in this conference.
Thank you so much, Doc. To the House, please, to the conference delegates, do we have any questions? Because it's been very, very interesting. Data is the core capability of digital technology. And a few things that we've learned.
That's true. So what we say here is about digital engineering is that traditionally we use other concepts as resources of projects. The concept of digital engineering framework is to make data a major source that we have in projects. So if you have human resources, if we have equipment, if we have money as our resources, we forget about something else. We forget about data and information, which might be one of the key resources that we have on a project.
Yeah, no. Thank you very, very much. Very interesting paper, lots of insights for us. And I'm sure I speak on behalf of everyone who's listening. Probably they're sending questions. Let me just see. Yeah, but I think like we've spoke even with Prof. Davids, if there are any further questions, we will send them through. But I think the message is very clear that you've put across to us. Even the issue of where BIM fits, being a construction term sitting there, and then maybe being part of the bigger digital engineering as more of an umbrella term, and a whole lot of food for thought, because even here, like in South Africa, we're not maybe at that level where things like this are, but that is the kind of research we're doing. We had even yesterday some papers on trying to do data sharing, and so I think this will really for us help us a lot. If there's not any further question, must we release our good doctor? For those who are having tea. But Doc, thank you so much. I don't see your hand up. Yes, thank you so much, and you enjoy the rest of the day.
So just to mention, these guys are really happy to get involved. If you have some people interested in communicating with Transport for New South Wales, I know their manager, and they are more than happy to provide training or to get involved with people who are interested to work with them. So I have the details for contact details for digital engineering Transport for New South Wales on their screen, and the link to their website. And also if you need any training, you can contact with them directly and discuss your intentions. Thank you.
That is generous. Thank you so much. I think the presentations, I'm sure we have them, or we'll ask for them if you could share them. Maybe we also get your presentation. We can upload them on our Asocsa, on our website, or maybe they'll go to the authors, then we can have the information as well.
Okay. Yes, sure. Thank you.
All right. Thank you. All right. Back to the house. Did we see those emoji hands clapping? Or did I miss those ones without my glasses? But I hope they're there. So thank you so much. I think what I just want to say now at this point is the tea time that is coming. After tea, I think Edwin there has already given us where we'll be, room A and room B. So each one will just have to check the links. Prof. Theo chairing the session in A, so he'll take you through that. And we need to see his face. There's nothing like you look better in the dark. Prof, we need to see you in the light. Okay, at least you showed your face yesterday and today. Dr. Frederick Simpe, we need to see your face as well in the light in room B. So from my side, I think it will just be for us to break for tea, and then we come back at 11. I'm not sure if there's anything else, Prof. Theo, maybe from the team that side on the ground that you may want to add on before people disappear. Thank you. You see, I have to get close. Okay, we're all good. So I think Edwin will take us out and then we'll be back at 11. Enjoy the tea. But I know for you, Doc, you said it's dark there, so probably not having tea this time. But for the rest of us, let's have a cup and then we'll be back. Thank you so much again to the both of you for the lovely presentation. All right, bye-bye.
Bye. Bye.
Thank you so much to all the
Pleasure.
speakers.
Yeah. Bye now.
All right.
Pleasure. Thank you.
Bye-bye.
To everyone, just some few pointers. Sorry, I have shared room B's link, but I have also created breakout rooms. So I think to be safe, for me to be able to make people or presenters co-host, it will be better to have 2 separate rooms. So please use the link that I have shared above to get into room B. So if the link keeps sending you back into room A, then sign out of your Zoom account and join a new meeting using the meeting ID plus the passcode, which I have shared as well. I hope that is clear and it's helpful. Thank you so much.
All right, thank you so much for that.
All right.
We've had some discussions about no one asking any questions. And I would like you to give these particular presenters a challenge by posting a question to each one of them. So we'd like you to actually participate. And you use the chat feature and you just address the question. So our first paper is called Cash Flow Management by Contractors by Kelly Koopman and Roy Cumberledge. Who's going to do the presentation?
Kelly Koopman will be doing
Is Kelly
it.
and
Can you hear me?
I can hear you. Where's Kelly?
I'll be doing the presentation.
Can I just quickly go through and see for each paper who is going to present the papers for each of the 4 papers that I have? Who's presenting the cash flow management by contractors paper?
Kelly Koopman.
Sorry, I can't hear you.
Kelly Koopman. Sorry?
So Kelly will present that paper.
Yes, yes, that's correct.
Okay, Kelly, then can you proceed?
No problem.
Oh, there you are. Sorry, snazzy. Okay, go ahead. Use the shared screen to upload your presentation.
May I begin?
Yes, you may go ahead. Make sure everyone else has muted themselves. Go ahead, Kelly.
Okay. Thank you so much for the opportunity. My name is Kelly Koopman, and today I'll be presenting my paper on cash flow management by contractors on behalf of the Nelson Mandela University in the Eastern Cape. First, I'd like to start off with a brief content of what we can discuss today. It will be a brief introduction on what my paper complexes of, defining cash flow management processes and techniques, then a slight research methodology of what I use to conduct my paper, my results and findings, finally a conclusion, and then lastly just a recommendation for you to be able to see what I have gained from this paper. Let's dive right in. In terms of an introduction, cash flow is basically defined as the lifeblood of the construction industry, because cash is typically considered to be the most important of a construction company's resources. Efficient financial management is a key factor in the successful execution of a project. Due to the long durations of potential construction projects, a large amount of money is required, and the need for effective cash flow in construction industries is intensified. As you can see, key factor is efficient financial management. This, in terms, will equal a successful execution of all projects. Industry failure rate. The construction industry is the foundation of the economy for the Eastern Cape province. However, the level of insolvencies within the construction industry reflected a higher rate compared to other sectors within the province. Considering the vast level of management capabilities existing within the building sector, one would not presume a lack of financial control combined with poor management to be the underlying cause of industry failure. Based on this finding, it was presumed that only through effective financial management would an organization be financially strong and survive in the long term. Construction industry failure rates were steadily increasing, especially in relation to contractors who did not effectively take precautions to manage their cash flows, deriving to the conclusion that poorly managed cash flow can be the driving force behind project failure and company liquidations. The purpose for this paper focuses on various cash flow management techniques, selected and incorporated by contractors into their daily processes and the effects of poor cash flow management on their businesses. It was perceived that contractors lacked the ability to implement adequate cash flow management techniques and therefore were not capable of meeting their monthly payments. A quantitative research approach was selected for the research, which focused on effective cash flow management techniques implemented by contractors and the effects poor cash flow had on the contractual parties affected by the contractor. A web link connected to an online questionnaire circulated within the Master Builders Association newsletter, aimed at contractors registered with the association. The average scores from the respondents was calculated, tabulated, and used to determine the degree of contractors' cash flow management capabilities. It was found that contractors were knowledgeable with regards to proper cash flow management procedures implemented. However, there were a lack of cash reserves combined with consistent late payments to contractual parties, resulting in many cash flow deficits. In order to understand the context of this paper, we would need to break it down into various groups. Firstly, what is cash flow? Cash flow is the balance of the amounts of cash being received and paid by a business during a defined period. Effective cash flow management is essential for the survival of the business. Payments from the client to the contractor are split in order to pay worker, warehouses, and businesses. Payment
Sorry,
from the client.
Kelly, can I just interrupt you? It seems that your presentation is frozen and it seems fairly small on our screen here. Can you enlarge it from your end and make sure that it actually flows? Because I'm not sure whether this is a static screen or something that you actually want to roll through in your presentation.
What screen are you seeing right now?
I'm seeing what is cash flow.
That is the correct one.
Is that the correct one? Okay.
I'm not sure.
If it's possible, see if you can. Are you using the presentation mode?
No, I'm
You
not.
should. That's probably why. If you use the presentation mode, your presentation will actually enlarge. There we go. Okay, proceed.
Okay, no problem. Okay, let me continue. Okay, what is cash flow management? Cash flow management is the process of tracking how much money is coming into and going out of your business. This helps you predict how much money will be available to your business in the future. It helps you identify how much money your business needs to cover debts. The implementation of meticulous financial management practices allows contractors to estimate the amount of cash that it would have on hand at any one time, project trends in cash inflow and cash outflow, and evaluate whether a shortfall or surplus in cash would potentially occur. Contractors must have money coming in to pay subcontractors and suppliers and additional day-to-day running of the businesses. This is crucial for its success. Still sticking to the same slide, further information pertaining to cash flow management. The money for prospective projects should come from the client. Therefore, if there is an insufficient inflow of cash, this may directly affect the contractor's cash position if their expenses are not carefully monitored. In terms of cash flow management processes and techniques, cash flow management processes within construction should support various decision-making processes. This will ensure the contractor's protection against the harmful effects of uncertainty. Producing information which effectively supports decision-making concerned with either cost savings, value improvement, or financial management has to be the main objective in cash flow management processes. There are 3 core cash flow management techniques identified in the study to help contractors improve cash flow management in construction. These are operational cost estimates, S-curves, and target costing. Let's dive into each one of these. Operational cost estimating. Operational cost estimating incorporates the use of activity-based costing for estimating the cost of resources pertaining to a particular construction project. What does activity-based costing allocate? What does it consist of? It consists of two-stage approach for allocating indirect costs to products based on cost diverse of various levels. The first stage of activity-based costing deals with resource costs such as labor, equipment, and power. These are allocated to those activities that performed in the organization. The second stage of activity-based costing is activity costs are allocated to the cost objects based on selected cost drivers, which express a causal relation between the activity demand and the cost object concerned, basically breaking down your activities into your resources and how your costs are split between the two. Cash flow S-curves. This is a graphic display of cumulative quantities plotted over time. The S-curve representation shows the utilization of inputs and resources over time. In the specific example given, the actual cash flows below are the original planned cash flows. And as we can see from the actuals, the line has deviated away from the original plan and current plan. This highlights the volatility of even the most predictable S-curves, with sharp deviations which destroy our perfect S-curve being entirely possible at the stage of project. This is the example depicted. Basically a plot of your original plan percentages versus your current actual plan percentages. That's an S-curve. And it's called an S-curve based on the flow of a slow startup in the beginning of a process, going to a higher middle or faster production, and a slow end out at the end of your project. Target costing. Target costing is used to reduce the total cost of the project in order to reach the estimated profitability while still guaranteeing acceptable quality levels. Target costing is more focused on the cost reduction during the design process, which encourages cash flow managers to set target costs based on market-driven selling prices, as target costing transmits the cost pressure placed on the firm by the marketplace to everyone involved in the process of project design. In terms of my research methodology, primary data was gathered through quantitative research. The descriptive quantitative method was used in this study. The selected population sample consisted of roughly 150 contractors registered at the Master Builders Association in the Eastern Cape. A semi-structured questionnaire was divided into 4 sections, with the first section pertaining to demographics of the respondents. The second section included cash flow management processes and techniques related questions. The third section included questions pertaining to construction project cost overruns. And the fourth section included questions pertaining to project delays as a result of late payment. Questionnaire administration was undertaken by distributing a pilot questionnaire to 5 contractors registered with the MBA. Then, to ensure the viability of the questionnaire and to evaluate the response of the participants to the overall questionnaire, the questionnaire was personalized and individually emailed to 150 contractors registered with the MBA, with a cover letter in the email and a link to a web-based survey where they could find the questionnaire. My results and findings: 51 responses were acquired from the 150 contractors emailed to partake in this research. Hence, a response rate of 34% was achieved. As can be seen, the majority of respondents were senior contractors. 88.24% of respondents were males, 64.70% of respondents were 40 years and older, and 66.66% of respondents had 11 or more years experience within the construction industry. Table 1, allocated in the slide, and Table 2, later allocated, both indicate various cash flow management statements and contractors' perception to these cash flow management processes and techniques studied above. Responses are based on ranking of importance. We can be seen in our findings that 68.60% of respondents strongly agreed that contractors need to utilize cash flow management processes and techniques into their companies. This is indicated by a high mean score of 4.67. Secondly, all 3 statements regarding various cash flow management techniques, such as operational cost estimating, cash flow S-curves, and target costing cash flow management tools, all indicated similar mean scores ranging between 4.2 to 5, which indicates that most respondents strongly agreed that their respective companies incorporated one or all of the cash flow management tools. when determining and planning their project cash flows. However, it was found that the most incorporated cash flow management tool was target costing. When asked whether the respondent's company finds itself without cash to meet their obligations, a rather split response indicated by a total of 37.26% of respondents either choosing to strongly disagree or disagree, 7.84% of respondents being neutral, and a total of 54.91% choosing to strongly agree. Based on these percentages, it cannot be stated that all the participants cohesively find difficulty meeting their financial obligations. However, with a high mean score of 3.37, which is almost in agreement with the statement, one could deduce that a large number of respondents find themselves facing financial difficulties come month end. This is the second table, which is just a continuation of the questions pertaining to the cash flow management techniques and processes. The findings continue as a total of 11.76% of respondents strongly disagreed, only 1.96% neutral, and a total of 86.28% of respondents strongly agreed that their respective companies received most of their cash from construction project payments. Based on these percentages of responses, it would seem a large majority of contractors who partook in the study only received most of their company's cash inflow from construction projects. However, a small portion of respondents seem to have created various supplementary platforms to obtain cash inflows. A response rate of 3.92% of respondents choosing to disagree, while 88.24% chose to agree, indicates that a large majority of respondents retain a certain amount of reserves within the company's bank account to allow their companies to meet future cash needs if they encounter financial problems due to a lack of work. Lastly, 88.24% of the respondents either agreed or strongly agreed that their company creates monthly cash reports, indicating that they have successfully implemented a cash flow management technique to ensure they have an efficient level of knowledge regarding their company's cash. Similar findings to the last reveal a mean score of 4.59, emphasizing that contractors mutually agree that they need to be timely in the payment of their bills to their subcontractors and all other service providers. The high mean score of 4.49 stresses that contractors are aware that a lack of cost control ultimately leads to business failure. Therefore, it seems that contractors are fully aware that not having proper cash flow management techniques in place will lead to their company's failure down the line. Conclusions for my investigation stem as the following. The current research undertook to investigate effective cash flow management by contractors, specifically within the Eastern Cape province. Numerous cash flow management processes and techniques were investigated, including additional testing on various impacts that would have harmful effects related directly to the company's finances. The research determined that contractors are aware of the effects of financial management and its impacts on their overall survival. Contractors seem to be aware that cash flow management processes and techniques need to be incorporated in their respective companies to ensure sufficient cash flow management. However, there were a large majority of contractors who had chosen to only implement target costing as their preferred cost management tool. A large majority of contractors do implement cash flow management techniques, when there are still those that do not. Contractors are experiencing cash flow deficits when trying to cover their expenses. However, there are a large majority of contractors who are not facing the same problem. Contractors are for the most part surviving based on income received from construction projects. However, this would be detrimental if the company had to encounter a stagnant period where they had no work. They are creating monthly cash reports to ensure effective cash flow management over the course of their projects, which will ensure they keep track of the expenses that they need to be covered each month and the profits being rendered. Contractors are all too familiar with being hounded by subcontractors and suppliers when outstanding funds are due to them. Thus, to ensure strong and lasting working relations, they need to be efficient in paying their respective parties. Without effective cash flow management practices, contractors will not survive. Lastly, my recommendations after this study. Looking forward into the industry, contractors should be educated and directed into implementing cash flow management processes and techniques more consistently on all of their projects. An alternative means of cash inflow, opposed to only that of construction projects, would be highly beneficial to any contractors. This would ensure additional reserves to meet any future cash-related needs, especially in terms of industry recession. Contractors need to fully investigate their contractual rights in contractual matters. This will ensure those suffering from the negative effects of late payments will be able to mitigate the situation in the most cost-effective manner possible. More project-specific budgets in terms of cash flows throughout the lifespan of the construction projects need to be implemented, allowing contractors the ability to foresee any hardships along the line and have sufficient amount of time to react and employ barriers against negative effects of their cash flow. All in all, the ineffective cash flow management will lead a solid foundation of a construction company into a failing business if the cash flow is not managed properly. As said in the beginning, if cash flow is your lifeblood of your company, what if your lifeline is pulled? What then? Will your foundation crumble? Where will you get an extra supply of cash? An example in terms of the pandemic that we've just faced. If a contractor didn't have cash reserves, his laborers or his workers would have to focus on trying to get UIF money to sustain themselves instead of having a company that could employ extra resources in order to ensure that the employees were financially stable at home throughout that period. This is just a fruitful thought in the future, that without solid cash flow management, your company will not be able to survive. Any questions? If none.
Thank you, Kelly. Don't run
Yes.
yet. Thank you for a presentation on a very important topic. If there are no other questions from any, I have just a few questions, maybe comments. What I wanted to know is, what was the level of your study?
The level of my study was very, very basic. It was at honors level.
Okay, it's honors. Okay. What I also wanted to know is, I know you did a survey using the MBA,
Yeah.
and I'm sure you used our good friends in the Eastern Cape. What was your response rate?
My response rate was only a 34%.
Okay. The reason I'm asking, and this is for everyone, that when you generally conduct research in South Africa in the construction sector, your response rates are pretty much low. So you have to literally pull teeth. So I just want to just do that for my own, information, that it's still the same. Whereas elsewhere in the world, if you did this kind of research, you'd have a much higher response rate. Just something else about, not so much the cash flow techniques themselves. I was wondering whether you had thought about what techniques could be used to actually monitor cash flow. Whether contractors were using manual systems, which could be fairly laborious,
Yes.
or whether they would have thought of using some automated systems that are available, or they could use, that would make it less laborious, but actually give them manageable information that could be useful.
Yes.
Or is that something you thought about?
I am actually, it's funny that you mentioned that. That is actually what my master's is diving into.
Great. Okay.
So,
So I loved your ending. Was very good. And I was just suggesting to you to think about, when you put presentations together, to use that kind of slide as opposed to a lot of text.
okay.
I just looked at it and it was very good.
What?
There are no other questions from anyone else. So thank you very much, Kelly. And I wish you all of the best with your master's degree
Thank you so
going
much.
forward.
Thank you.
Thank you. We now move on to our next paper, which is authored by Lindelwa Sinchadi, eliciting project managers' perceptions regarding economic sustainability, incorporation on construction projects, a Bloemfontein case study. Are we ready to rock and roll on this particular paper?
Yes, Prof. Good morning, everyone.
You can proceed.
Okay. Can you see my screen?
I can see your screen. Can you just use the presentation mode, please? Okay.
Okay.
Thank you. Go ahead.
Okay, good morning, everyone. My name is Lindelwa Sinchadi from Central University of Technology. And the title of my study is Eliciting Project Managers' Perceptions Regarding Economic Sustainability in Cooperation on Construction Projects, a Bloemfontein case study. The outline of the study includes the background, theoretical lens, research question and aim, research method, discussion of preliminary findings, and the conclusion. So starting with the background to the study, construction industry plays an integral part in sustainable development. So to understand, okay, the sustainable construction is a holistic process that aims at restoring and maintaining harmony between natural environment and built environment. So the project managers in this instance are integral in the quest for sustainable construction. We have 3 dimensions in sustainability, that is social, economic, and environmental dimensions. So evidence indicates that the different dimensions have been prioritized by project managers during the delivery of construction projects. And this has been attributed to the level of knowledge or the perception of project management team. Then it has been observed that there's limited literature that is eliciting perspectives of project management professionals within the South African construction context concerning the consideration of economic sustainability in sustainable construction practice. So this is the study, this is the gap that the study seeks to fill, even though the study starts with preliminary data collection from a Bloemfontein case study. Then coming to the theoretical lens, 2 concepts are being used in the study, that is sustainable development and sustainable construction. And these concepts are 2 sides of the same coin. So to understand the meaning of sustainable construction, it's important that we understand or we explain the meaning of sustainable development, which refers to the development that meets the needs of the present without compromising the ability of the future generations to meet their own needs. So construction, sustainable construction is used as a cross-cutting concept because different scholars define it in different ways. For example, in this instance, it is a division of sustainable development and its application to the construction industry. So sustainable construction integrates the various sustainability dimensions, that is economic, social, and environmental, in a manner that is depictive of trade-offs dependent of the project peculiarities. So in this case, the perception of project managers regarding the aspect of economic sustainability is to ensure that value is added to the quality of life for individual and the community. There's also the principles of sustainable construction that have been identified. For instance, the minimization of resource consumption, maximization of the reuse of resources, the use of renewable and recyclable resources, creation of non-toxic and healthy environment, including good quality of built environment. On the other hand, there's also challenges that have been identified, like the lack of capacity to implement sustainable practices within construction industry. There's also a lack of awareness of sustainability issues by some of the project managers, and the economic success is affected. Also, there's lack of public awareness, lack of commitment by top managers, as well as sustainable practices. Other scholars have even identified other barriers in sustainable construction management, which includes financial, political, managerial, technical, socio-cultural aspects, and knowledge. Then coming to the research question and the aim. The research question is, what are the perceptions of project managers concerning the aspect of economic sustainability in the construction industry? So the study seeks to explore the perspectives and the understanding of project managers on economic sustainability. Also, the study seeks to identify the factors that are influencing the prioritization of economic sustainability aspects to secure satisfactory trade-offs. Then coming to the research methodology. The study adopts a qualitative case study research design. And in this study, 6 project managers gave permission for the semi-structured interviews. And the data was collected from private and public sector organizations. And these project managers are working on projects within the Bloemfontein area. So relying on the predetermined themes, the data was analyzed by identifying the excerpts from the transcripts which were aligned with these themes. Then the preliminary findings. The first theme is the level of sustainability among the construction project managers. Under this theme, there is an appreciable level of knowledge concerning sustainability among the project managers that were interviewed. However, the degree to which sustainable development dimensions are implemented on the projects is largely dependent upon the requirements of the client. Also, under this theme, it was observed that whereas most of the project managers were aware of the concept of sustainability and sustainable development, they were not particularly certain about the various aspects of the different sustainability dimensions, that is social, economic, and environmental. And then the second theme is understanding of economic sustainability by the project managers in construction industry. So from the findings of the interview, it was apparent that although most of the interviewees understood the aspects of economic sustainability dimension, they did not recognize these aspects as economic sustainability facets, but rather they felt that these aspects belong to either social or environmental sustainability dimensions. So the economic sustainability aspects that were identified by the participants included activities that were central to improving any or the combination of different activities. For instance, they included the cost and material effectiveness on the project delivery process, the profitability of the firm and the client organization, as well as the expected and actual contribution of the project on the economy of the area. Also, the interviewees averred to the criticality of the analysis techniques, such as the life cycle analysis and the life cycle costing approaches in engendering effective decision-making as it concerns various aspects of sustainability dimensions on the projects that they were involved in. Then moving to the perceptions of the contribution of economic sustainability in cooperation to effective project management of construction project. All the interviewees noted the potentials of the projects to contribute to solving most of the societal challenges, such as unemployment and the increasing rate of project abandonment if aspects of economic sustainability dimensions are prioritized. Also, they insisted that such prioritization should be made at the inception of the project life cycle, as well as across the entire life cycle of the project. However, there were some of the interviewees who indicated that there are budget constraints which form part of the barrier in prioritizing the aspects of economic sustainability during the development of the trade-offs between the three dimensions on the project that they are involved in for different reasons. Then the last theme involves the role of the project managers concerning the incorporation of economic sustainability in construction management. On the project managers that were interviewed, there was a consensus between them concerning the role of project managers in either engendering optimal incorporation of economic sustainability or buttressing its prioritization during discussions on securing the trade-offs between different sustainability dimensions at different phases of the project management. However, they also noted that these roles are abridged by other factors. For instance, the client requirements as well as the existing policies that are governing the projects that they are involved in. They also highlighted the need for more enlightenment of project managers on the increasing need to prioritize economic sustainability aspects on their projects. And then in conclusion, the study set out to explore the understanding of economic sustainability by project managers within the construction industry. The findings confirmed that project managers understand economic sustainability within construction projects. However, they also indicated that the level of incorporation and prioritization of economic sustainability aspects was mostly dependent on the various aspects such as the requirements by the clients, as well as the legislation that was used on their projects, and not the knowledge or the skill set of the project manager. So it is expected that the study's findings will be taken into caution, as the findings are merely preliminary at this stage. So further data will be collected using the questionnaire survey. I thank you.
Thank you, Lindelwe. Just a question from me. In fact, there was a question from someone else which says, how many project managers from the public sector participated? How many were from the private sector? Maybe you can respond to that, and I'll pose my question.
Okay, I managed to get only one from the public sector, and then 5 were from the private sector organizations.
Okay. What I was interested to know is what analysis process or techniques did you use? Was there any specific software, especially when you're analyzing themes? How did you go about doing that?
I did not use any software. It was just done manually.
Okay, because I suppose because the sample was fairly small.
Yes.
Okay. I am asking everyone to rate any papers that are presented by women or female co-authors or presenters, because Asocsa has a sponsor for the best paper presented by a woman or female presenter or co-author. So don't be shy, because we will use these scores in making that determination and hopefully communicate the outcome at the end of the conference if we are able to.
Okay, Prof.
Thank you, Lindewa. We are
Thank you, Prof.
moving on to a paper, assessment of management strategies for residual on-site related risk factors in educational institutional building projects. We have 3 authors, Olamide Adara Legbe, Akintoyo Opawole, and Kahilu Kajimo Shakante, our president. So please proceed with that presentation. Thank you. Who is doing the presentation?
Tayo was ready for the paper. I think was told to just unmute, so I'm not sure what's going on there.
I'm actually unmuting him. Please.
Good morning.
Thank you.
Good morning.
Morning to you. Are you ready to present?
Yes. I'm presenting from Nigeria.
Okay.
So I'm presenting for Olumide Adalegbe, Akitayo Paole, and Ilu Kajimo Sakantu. So the topic of our paper is assessment of management strategies for residual on-site related risk factors.
I can tell you, I can tell you, excuse me, have you got a presentation?
Yes, I've started.
We need you to
Can
share
you see my
the screen.
slides?
No, I can't.
Oh.
Can you share the screen?
Yes, I can see you.
Yeah, but if you click on the green button at the bottom, then what is on your screen will appear for us to see. It says share screen. Can you see that?
Yeah.
Now you need to.
Can you see now?
It's opening, okay? Now will you also click on the presentation mode? Yep, down there. Go down. Just click on that so that we can see the presentation.
Sorry, Chair. The slide, show slide.
Yeah, you must click on the slideshow format.
Yeah.
On the right hand side next to 100%. If you click on that icon at the bottom, go down. Yep, that one. There you go.
Can you see?
We can see it now. Thank you. You can
Okay,
proceed.
Thank you so much. The title of our paper is Assessment of Management Strategies for Residual On-Site Related Risk Factors in Educational Institutional Building Projects. A snapshot of the presentation. There are a number of ongoing projects within the education sectors in Nigeria, and it is expected from the stakeholders that most of these projects are expected to perform better than projects from other clients. And the reverse is the case because we have a situation where most of the projects exceed the expected parameters in terms of cost and time. And our earlier study had revealed that most of these project variables have been impacted negatively by elements of risk factors. So we have considered effective management of these risk factors as an antidote for successful project delivery. So in this regard, in the case of this paper, we have considered a quantitative assessment of risk occurrence, impact, and management strategies that have been employed on those projects in order to minimize the effect of the risk variables on the project parameters. And this study will enable practitioners to gain profound insight into on-site related risk management strategies that could be suitable for building project management generally. The study is also expected to highlight implications for design of formalized risk management strategies that could be used for specific building operation. Introduction. The magnitude of variance between the projected and actual performance parameters in terms of the quality, cost, and time, as I've earlier explained, could sometimes be very high, as it has been the case in most of the building projects in most of the tertiary institutions in Nigeria. And the reason for this is because most of the risk factors that impact on this project appear not to be well mitigated. So in the case of site-related factors, it is a significant component of risk variables that impact construction projects that have not been really focused specifically by researchers. Most of the researchers on construction risk management, they have considered risk variables altogether for the various stages of a project. But if you look at the site stage in a construction project, we know that it is defined by a number of characteristics that are specific to that particular stage. We have a number of variables like geotechnical uncertainties, and of course, the construction stage is the longest of the phase in a project delivery. So we have considered an efficient management of risk factors at this particular stage of project delivery to be of an important input to a good performance in the case of project delivery. Risk management, by way of definition, is a systematic practice of management policies, procedures, and processes that are related to activities on analysis of risk, their evaluation, and control. We have a number of risk variables that have been identified in previous studies, both that are related to the whole phases of a project generally, and those that are specific to the construction stage of a project. From our survey of existing studies, we are able to identify about 52 risk variables that impact the construction stage of a project delivery. So there is, it appears there are no researchers that have actually provided blueprint for a well-structured and coherent process of effective risk management during site operation. And this is the focus of this study. By residual on-site risk factor, we have considered it as remedial action involving strategies, methods, tools, models, and procedures necessary for dealing with risks that have been accepted during management process of risk on a construction project. And the purpose of this study is to evaluate strategies that contractors have adopted for managing this set of risk variables which impact project performance at the construction stage, so as to provide information that could enhance the establishment of valuable risk management framework. Methodology for the study. The study was done through the head of structured questionnaire, and the participants involved in the study are contractors that have executed projects in tertiary institutions in Ekiti State, that is in southwestern Nigeria. Within the period of 2016 to date, we have captured 2016 to date to make sure that those contractors, they could still have up-to-date information of their project they have executed and how they have gone about managing the risk factors that they encountered in the project. And we still believe that they will still be able to recall their experience and how they were able to go about managing those risk factors. So as Apelia said, the research instrument is structured questionnaire, and the sampling technique we use to select the participant for the study is purposive. We targeted only respondents that have executed projects in tertiary institutions within Ekiti State in southwestern Nigeria. So we are able to get 52 professionals comprising of architects, builders, engineers, conservators, project managers, procurement officers, and land surveyors. And the data collected were analyzed using mean item score and standard deviation. The result of the profile of the respondent indicated that the professional, the respondent with the least academic qualification are those with higher national diploma. And this only represents 23.7% of the total respondents. Others have either first degree, master degree, or PhD. The year of experience of the respondent was estimated at 11 years, and this only represents, with about 21.1% of the respondents having between 11 to 15 years. Almost all the respondents are related to one or more of professional affiliation, which include the Nigerian Institute of Quantity Surveyor, Nigeria Society of Civil Engineer, among others. The strategies adopted for site-related risk factors. We identified a number of strategies which include brainstorming, specification of ISO 3100, strict adherence to occupational safety and health, contingency sum, interview with specialists, David method, change analysis, event and causal factor charting, sensitivity analysis, among others. The rating of these variables on the questionnaire indicated that brainstorming is the one that was mostly adopted by the contractors in their previous project, which was followed by specification of ISO 3100, and then followed by strict adherence to occupational safety and health and contingency sum. Brainstorming as highly rated suggests that generation of exhaustive ideas necessary for design of risk catalog and management strategies is feasible. Also rated is contingency sum, which indicate that if this management strategies is well developed, it could help to cushion the effect of cost overrun on construction projects. The study suggests that expected monetary value, risk breakdown model, human reliability assessment, use of safety precaution, contingency sum are the most effective management strategies for mitigating cost at time overrun. Whereas sensitivity analysis, risk breakdown structure, brainstorming were found to possess the highest degree of potential for reducing cost overrun. How did we get this one. What we did was to collate projects that were executed by this set of contractors. We look at the projected performance variable as in the initial cost, the initial time, the final cost, and the final time. So we now try to analyze from their document the risk management strategies that were adopted on most of those projects. And we now compute the degree of variation between the initial and final time, and then the initial and final cost. And we're now able to come up with a situation where, like in the case of some of the projects, like about 22 number, where they used expected monetary value, we could see that the percentage variation in time, that is the variation from the initial and the final time at the completion of those projects, averaged 8.82%. And in about 12 projects where this breakdown model was used, we found out that the average of cost of time overrun on the project was 12.44%. Same with human reliability assessment and the fourth rank most adopted strategies, which is use of safety precaution. In that case, we had average of 20% time overrun. The same thing for cost overrun. We could see that where sensitivity analysis was adopted, there was a variation of 57.58% between the initial and the final cost. And for risk breakdown structure, 4.43%. And in the case of brainstorming, actually, we perceive some kind of foul play among the contractors with respect to what happened to projects where they adopted brainstorming and contingency zone. And why contractors do that in Nigeria is to make sure that they have a kind of what will help to project or protect their image so that they will have opportunity for future engagement. So most of them, they try a kind of manipulation of the final cost so as to make sure that it at least at a very little variance from the initial cost. And in conclusion, we have to conclude that brainstorming specification of ISO 3100, strict adherence to occupational safety and health, contingency sum, as well as interview with specialists, have received some applications among those contractors that have been involved in the project within the education sector. Meanwhile, sensitivity analysis, expected monetary value, risk breakdown structure, and brainstorming were found to offer better efficacy with respect to mitigating time and cost overrun. So the key lesson from this study is that practitioners can gain insight into those management strategies that could help or that could provide edge over others with respect to minimizing the variance between the initial and final parameter, the indices of project parameters. And we recommend that choice of appropriate management strategies should be based on the criterion as indicated with respect to how those strategies are able to mitigate the degree of variation between the final and initial time and cost overrun. We expect a further evaluation of those the risk variables that are mitigated by these strategies to the tune of understanding their severity so that the assessment or choice of risk management strategies for those individual risks could be based on the severity indices of those risk factors. Thank you for listening.
Thank you very much, Akintayo. I see you said donkey, very good for a Nigerian. I have two comments. One is a comment and the other is a question. I don't see any questions from anyone else at this stage. My one comment relates to your references. You've got one instance of a 1999 reference that you use, and then you also have PMI 2004, which is almost 16 years old. So I would suggest that you really look at those and see if you can find more recent references. And then just an observation, you looked at risk factors in educational institution building projects. What I wanted to know was what makes those kinds of projects any different from other structures?
Actually, what we had in mind is to look at what is happening in an educational building project, so as to provide. We thought it could provide a good lesson for project management with respect to risk factors in other building projects, because in the Nigerian setting, it is always assumed that everything within the education sectors will provide a kind of model for others to follow. So every project within the sector is expected to go through all the necessary formal arrangements. Within the physical planning and development unit, we have professionals that are versatile, and even before they will bring any contractor to come and engage to execute project within the institution, they always look for most competent contractors. So, and we expect that if that is the case, projects that are executed within the educational sector are expected to have the best of the performance indices. But the reverse is the case. We now noted that most of the problems we have with the project they relate mostly to the construction stage. So we now try to look at what is really happening at the construction stage of projects that are executed within the education sector, so that lessons gotten from there could be used to develop better management strategies for risk factors in other projects.
Okay. I think you do need in your work to clarify specifically why you are looking at that particular sector. What makes it different? What are the demands on the client, etc.? The different stakeholders in that whole process, how different are they from any other types of structures? Because that might be the context in which you're conducting your research, but it does not necessarily make the assessment of the risk factors any different from anywhere else, unless you make a clear distinction. Okay. But that's just a thought for you to think about going forward. But thank you very, very much for your presentation, and stay well and healthy, because you said to me that you were actually still in Nigeria. I've also asked for this paper to be rated. Please send it to me privately. You look for my name and you click on it and you put your score in there. It would be very helpful to us. The final paper in this session is the impact of cost overruns and delays in the business of construction. And the paper is authored by Mpiwe Dlamini and Roy Cumberledge, and I presume that Mpiwe will actually do the presentation. Please proceed. Mpiwe, are you there? Mpiwe, okay, she is here. Can you upload your, and have you unmuted her? Shows muted.
Okay,
Okay, good. I can hear you.
okay.
Will you also use the presentation mode?
Can you see
Thank
my
you.
screen profile?
Thank you very much. You may proceed, Mpiwe.
All right, thank you very much. Good afternoon, ladies and gentlemen. My name is Mpiwe Dlamini. I will be presenting a research paper entitled The Impact of Cost Overruns and Delays in the Business of Construction, which was compiled by me and my supervisor, Mr. Roy Cambridge, for my honors degree from the Nelson Mandela University. My agenda for the day is as follows. I will start with the introduction, then go to my literature review, methodology, results and analysis, conclusions and recommendations, and lastly, I will take questions from the audience. Introduction. Currently, the construction industry is still fighting challenges of cost and time overruns. Construction delays and cost overruns are a global phenomenon. Regardless of the usage and introduction of software packages, cost and time overruns are still popular. The graph basically shows a study that was conducted in 2011 across the world to study project failures. The results showed that the Channel Tunnel in the Europe experienced cost overruns of about 80%. 200% overruns occurred for the Denver International Airport in the United States. The UK National Health IT Service was up to 700% over budget, while the Egyptian Suez Canal experienced 1,900% overruns. So the authors of the papers found that there was a link between cost overruns and project managers' competencies. Then coming to South Africa, between 2012 and 2014, the Medupi and Gusile projects were poorly managed. Coming to the current gap of my study, the project manager is considered to be the key contributor to the success of any project. The project manager's roles, duties, and competencies have a direct impact on the success of construction project. There is a strong correlation between the project manager and the success of the construction project. However, the project managers are lacking key competency skills, resulting to cost overruns, which ultimately leads to time delays. So this brings me to the objectives of my study, to identify project managers' key competency skills that reduce cost overruns. To identify project managers' key competency skills that eliminate time delays. And lastly, to identify mitigation measures for cost and time delays. Moving to my literature review, cost overruns can simply be defined as an excess of actual cost over budget. So in construction, cost overruns are considered as one of the most frequent problems that impaired project progress. So the significant factors causing cost overruns were categorized as follows: planning and control, site conditions, market fluctuation, scope change, of which planning and control by project managers was the most dominant factor. Riggs identified the competencies of project managers under three distinct categories as follows. There were the key competencies, core competencies, and optional competencies. From these categories, the following competencies were relevant to reducing cost overruns. From key competencies, we had planning and control, personal and interpersonal skills, coordination, communication on site, management of cash flow, leadership style. Then from the category of core competencies, we had financial control on site, implementation of technology, strategic implementation, decision-making, negotiation skills, business skills. From the optional competencies, we had arbitration and dispute resolution, design abilities, and application of project budget. So just to elaborate one example from the list, planning and control is about setting out goals for every stage of the project to ensure that the project manager can adapt and change those plans. For instance, in some cost overrun study, you find that lack of planning of health and safety will cause too many injuries on site, causing unplanned expenses, which concurrently delays the projects. So that's why my study focused on both time and cost overruns. So time overruns are defined as an extra time required to finish a given project beyond its original planned duration, whether compensated for or not. Delivering projects within the contract stipulated time is one of the yardsticks of measuring a successful project. So the significant factors causing time overruns we categorize as follows: compensable delays, critical delays, excusable delays, and non-excusable delays. So according to Ngando and Meyer, the following project managers' key competencies were identified to eliminate time delays, and they were as follows: time management techniques, risk management, conflict management, planning and scheduling, communication skills, site organization, application of construction methods, decision-making, strategic implementation, procurement, and financial management. So just to elaborate, a study was conducted in Malaysia to evaluate the effectiveness of time management software. And it was found that most contractors do have time management software in place, but the project manager lacked the necessary skills to operate those applications. Moving to my methodology, the research approach followed in this study was the quantitative research using the MENO method. The data collection method was the semi-structured questionnaire using a Likert scale, which was divided into, having a questionnaire that was divided into 4 following sections. It was the demographic section and the section of sub-problems, of which it was the causes of cost overruns and the causes of time overruns, and there was the general section. The population was the construction professionals that were registered with the Masters Builders Association. The sampling method used was the random sampling method, and the treatment of the data was descriptive statistics. And the respondents for my questionnaire was 54 respondents from 32 contractors. Demographics. The demographics shows that majority of the respondents were project managers. 83% of the respondents were male, 37% of the respondents were 50 years and older, 33% of respondents hold a national diploma, 50% of the respondents have spent more than 15 years in the built environment, and then 41% of the respondents fall under the construction management constituency. Table 1 and 2 examine the data by ranking the level of importance and evidence on project managers' key competencies. The mean for each factor was recalculated as a percentage and ranked based on the level of importance and evidence of each factor. So from the table, planning and control was ranked the highest in terms of level of importance and evidence. A score of 98% was achieved for the level of importance and 97% for the level of evidence. Financial control on site was ranked the second place with a score of 94.4%, and ranked the 4th place for the level of evidence with a score of 92.2%. Ranked number 3 was the application of project budget techniques with a score of 94.1%, and 2nd place for the level of evidence with a score of 95.2%. Ranked 4th place for the level of importance was the management of cash flow with a score of 92.2%, and 3rd place for the level of evidence with a score of 93.3%. Ranked 5th place for the level of importance was the strategic implementation with a score of 87.4%, and also 50 for the level of evidence with a score of 85.2%. So based on the findings, financial control, planning and control, application of project budget techniques, management of cash flow, and strategic implementation were recommended as the key competency skills by project managers. Table 3 and 4 examine the data by ranking the level of importance and evidence on the project manager's key competencies. The mean for each factor was calculated and ranked based on the level of importance and evidence for each factor. So from this table, planning and time management techniques were ranked 1st and 2nd place respectively for the level of importance with a mean of 4.87%. Time management techniques was ranked 1st place for the level of evidence with a mean of 4.85. Planning and scheduling was ranked 2nd place with a mean of 4.81. Application of construction methods was ranked 3rd place for the level of importance with a mean score of 4.67, and in the same way for the level of evidence. Risk management was ranked the 4th place for the level of importance with a mean score of 4.57, and 5th place for the level of evidence with a mean score of 4.52. Decision making was ranked 5th for the level of importance with a mean score of 4.56, and 4th place for the level of evidence with a mean score of 4.52. So therefore, based on the findings, planning and scheduling, time management, application of construction method, decision making, and risk management were recommended as key competency skills by project managers. Moving to my conclusions. A project may be considered to be a successful project only when it is completed within the budgeted cost. Key competency skills are required by the project manager to control cost and time overruns. So based on the findings, it can be concluded that project managers do possess the key competencies, as this was supported by literature and the findings. So therefore, project managers may not be exercising key competency skills on site, or there are other factors causing delays. Moving to my recommendations, it is recommended that the South African Council of Project and Construction Management, the SACPCMP, be encouraged to focus and emphasize on the key competencies that which affect costs and time delays. Project managers need to equip themselves with knowledge of cash flow, budget, planning, risk management, and strategic implementation. Clients should ensure that they appoint fully competent project managers with a proven track record of completing projects within allocated time and budget. So this brings me to the end of my presentation, ladies and gentlemen. Thank you for listening to my presentation. I can take questions.
Thank you, Piwe, for your presentation. Before I forget, may I just remind everyone that listened to score the presentation or the paper on the scale of 1 to 5, and then send that score to me privately using the chat drop-down menu. I need to use those those scores. I know there were a couple of general comments about the presentation. One, for example, that an equal mean should equal an equal rank. You didn't show the standard deviation, which would have showed whether those means are somewhat different. In the absence of that, you would then have to have two equal means having the same ranking. Another point that someone raised was a quantitative approach is not a research approach. Research approaches include deductive or inductive approaches. So just bear that in mind. What I found with I have a lot of questions, but I won't elaborate on them all now. But it seems to still be premised by the TCQ paradigm, which is time, cost, and quality. Competencies relative to health and safety management, environmental management. What about innovation and creativity? The use of the latest advanced technologies, as we've heard over the last 2 days, are surely features that need to be taken into account. So I would suggest that you look at those competencies that you've identified by Ancado, which, by the way, are very dated anyway, because I think they were about 10 years old, and look at how you deal with some of the other parameters which are very critical for project managers in contemporary construction.
Yes.
Okay, there's a question from Professor David Edwards. The question is, what is the product of the research? What form will that product take? Anyone, and including yourself, you are free to respond to that. You can either answer yourself or actually type your response in the chat. I'm talking to those that are not you. So what is the product of the research, and what form will that product take? In other words, what are you trying to produce through your research? You don't have to groan. We're all here to learn together.
I'm not sure if the product has to do with the value of the research. Mm-hmm. I'm just asking a question.
I think so. I think so.
Basically, the value of the research is basically to assist construction managers to choose the right candidate as a project manager, and also assist inspiring project managers to acquire the key competency skills necessary for a project manager. I'm not sure if that is correct.
That's a good response. Yes. The challenge, though, is where will they find opportunities to gain those additional competencies post graduation from maybe a university? What opportunities are there?
I think maybe there can be like extra courses for project managers to get equipped with the necessary competency skills.
Okay. Professor Edwards suggested or asked the question, how will they do that? What tool will they use? Is it software, a decision support tool, or something else? So I think the point is, Mpiwe, you've got to think out of the box. We live in a very different world where change is the only constant, and things are developing at a rapid pace. So we cannot expect project managers to be static in terms of the competencies that they need.
Okay. Okay.
Right. So thank you very much for that. Do not forget to score Mpiwe's presentation, and we break for lunch. After lunch, which is at 1300 hours, room A will be chaired by Professor John Smallwood, and room B by Ferdinand Fester. So enjoy your lunch, and we will get back to you at 1 o'clock. Thank you.
Thank you very much.